Okay, so the third and final type of conversion that you'll have to do for this test is to convert from grams of one substance to grams of another substance. So if you look at your flow chart, if we're going to go from grams of chemical A to moles of chemicals A to moles of chemicals B and then to grams of chemical B, you can see that we need 3 stops or 3 conversion factors to finish this type of problem. So since we need 3 conversions, we're going to draw 3 T-charts. Okay? And then the problem gives us, this is the question we're going to answer, how many grams of sodium silicate can react with 0.8 grams of hydrofluoric acid? So it's going to give us 0.8 grams of hydrofluoric acid, or 0.800 hydrofluoric acid. Okay? And if you look at your flow chart, you can see that the first stop, as we go from grams of hydrofluoric acid to moles of hydrofluoric acid, is to use the molar mass to convert grams to moles. So to do that, we're going to put 1 mole of hydrofluoric acid on top, okay? And then we need to find out the molar mass of hydrofluoric acid. Well, hydrogen is 1, fluorine is 19, so if we add 1 and 19, we get 20 grams of hydrofluoric acid, okay? So if we just stopped here, this would give us the number of moles of hydrofluoric acid. But now what we have to do is we have to use the molar ratio of hydrofluoric acid to sodium silicate to convert this to moles of sodium silicate, as you can see if you look at your chart. So to do that, we actually have to do moles of hydrofluoric acid on the bottom, okay, because that's what we're converting from, which is A. What we're converting to, which is mole B, would be sodium silicate, okay? And if we look at our equations over here up top, okay, what we're going to have is, for sodium silicate, we're going to have 1, because if you look right here, there should be a 1. I mean, there's nothing, but if we assume it to be a 1, and if we look at hydrofluoric acid right here, there would be an 8, if you look at the balanced chemical equation. Now, if we stopped here, what this would give us is how many moles would react with 0.8 grams of hydrofluoric acid. That's not what we want. We want how many grams of sodium silicate, not how many moles. So now what we need to do is go from moles of sodium silicate to grams. So to do that, we got to multiply by the molar mass. So on the bottom, we're going to have 1 mole of sodium silicate, okay? And then on top, we're going to have the number of grams, excuse me, that would be 1 over here, and the number of grams of sodium silicate, okay? So if we add it up, if we calculate the molar mass, we need to break down the formula. So in the formula, Na2SiO3, we have 2 sodium atoms, we have 1 silicone atom, and we have 3 oxygen atoms. Okay? So if we look at the periodic table, we can see that the atomic mass of sodium is 23, and we have 2 of them, so we need to multiply it times 23. Okay? That gives us 46. If we look at 1 silicone atom, silicone has an atomic mass of 29, so multiplying it times 1, we get 29. And then oxygen, since we have 3 of those, we'd multiply 3 times 16 is 15.9, but we're going to round it for simplicity to 16. So 3 times 16 is 48. Okay? Now we add those 3 together, and we should get 4 there. Okay, and then 4, 8, 10, plus the 2 is 12. So we should get about 122 to 124 grams, depending on where you rounded. So we'll just say 124 grams is what we get. Now all you do is multiply everything on the top, and then divide by everything on the bottom. So divided by this. Once you plug in all the numbers in the calculator, you should end up getting something that's equivalent to about 0.61 grams of sodium silicate. So that you get something like this. And that's all there is for all 3 types of conversions. Just follow your flow chart and you should be able to do it without a problem.